GCSE Astronomy Topic 11, the size of the solar system. How big is the solar system? Now, the planets orbit the Sun in the same plane, approximately. Some of them are slightly tilted, but approximately the same plane called the ecliptical plane. Because all of the planets formed from the same disk of material 5 billion years ago, they're all orbiting anti-clockwise in the same plane. We say that the Earth is one astronomical unit, 1 AU from the Sun. And then this diagram here, the distances from the Sun are to scale. And hopefully you can clearly see that there's the 4 small rocky planets close to the Sun, and then the big gas giants much further out. There is an excellent video you should watch, a National Geographic video, where this guy builds a massive solar system to scale in the desert. It's very interesting. Now, Kepler's third law tells us the relative distances, but how do we know how far away the Sun is? How do we know what 1 AU actually is? Now, the way that we do it, the way that it was done, was to use something called a transit of Venus. A transit of Venus is when Venus is seen to pass over the face of the Sun. These are very rare, more than 100 years between them. There was one in 2012, which I was lucky enough to see. The one before that was 1882. So they are very rare. Now, interestingly, if you observe a transit of Venus at a latitude up in the northern hemisphere, and you also observe it in the southern hemisphere, what you notice is that the transits cross the face of the Sun in different places. And if we take measurements from the northern hemisphere and the southern hemisphere, we can calculate 1 AU. We can calculate the distance between the Earth and the Sun. Now, I'm not going to explain it all because you're not going to have to, and I don't want to confuse you, and it's a little bit tricky, but basically we observe the transit from, look, there's point A and point B. A is in the northern hemisphere, B is in the southern hemisphere, and if you know the distance between A and B, and you measure the angle that the two transits subtend on the surface of the Sun, then you can work out the distance from the Earth to the Sun using trigonometry. Once you know the distance of the Earth to the Sun, then Kepler's third law, do you remember t squared over r cubed equals 1? You can work out how far away everything else is from the Sun. A little bit of history now. 1639, Jeremiah Horrocks, an English bloke, predicted and observed a transit of Venus. In 1716, Edmund Halley, who they named a comet after, suggested a method for working out 1 AU using a transit of Venus. He never managed to do it though, but then in 1769, there were several different countries sent expeditions, but the British sent an expedition led by Captain James Cook to Tahiti to observe the transit of Venus. After he'd done that, he went off and did some exploring and stuff. Okay, then in 1882, lots and lots of different countries sent lots of expeditions.